And by the way, like if you look at this board, which I designed here in the corner, there is literally a DC-DC step-down converter.
If you're
that is the recommendation generally.
If you're taking power from the DCC bus, you could end up with an issue with ground potential differences, right? Your negative voltage, if that's connecting to a common ground on the CAN cable and stuff like that, you need to be careful about that.
Yes, that is true. It's true-ish. I mean, if your DCC bus has a thick enough wiring, and you have the usual bridge rectifier, then you're actually feeding your capacitor between the bridge rectifier and the ground of the CAN bus. But generally, you would only feed it from DCC if you don't have CAN bus. Because if you have CAN bus, if you have CAN bus, you don't actually feed from the CAN bus. Then you feed from the same wires. If you don't have the CAN bus, you use the Wi-Fi, then you would feed from DCC, and you don't care about the potentials, like they're floating.
So my use case that I was wanting to try and accommodate was where we've got Freemo modules, and I may have a node that talks Loconet for turnouts and signals and stuff like that and block detection, but also does Wi-Fi and does the whole thing for LCC across Wi-Fi as well as Loconet sort of thing. That was kind of what I've been pondering for a while.
Yeah, you can probably do that with an ESP32. The only thing that you need to be careful about is how many different clients connect to that Wi-Fi. And if the answer is 1, 2, 3, that's fine. If the answer is 25, that's not going to work with an ESP32. Then you need something with a real processor, like a Raspberry Pi or something like that.
Where is the constraint there?
The constraint is usually managing the TCP sockets and managing the textual communication on the TCP sockets. So for like a Linux machine, like a Raspberry Pi, it's no problem to have like 100 TCP sockets and send and receive the text there. There's no problem. But for like an ESP32, like you are limited on the number of sockets to begin with because of your RAM. You have very little RAM, and then the juice in the CPU is just so much less. It is not a performance optimized CPU, and it's running at very, very low megahertz compared to anything like a Raspberry Pi.
So this is for the hub process for all of the nodes to connect to.
Yes.
Okay. All right. So if I was using, Ubiquiti Unify Wi-Fi, there shouldn't be an issue with number of stations connected at once to Wi-Fi. And then if you've got, a PC or JMRI or a Raspberry Pi running the hub process, then that should work quite well. Yeah. I was always sort of concerned about mixing, the use of CAN and Wi-Fi together and blowing buffers somewhere. That was sort of always my concern.
Yeah, that's not going to be a problem so long as your CPU is reasonably okay. So it's not going to be a problem to like translate 1,000 packets. The problem is when you need to translate like 25,000 packets, so that sort of stuff. And it also throttles the other way. So the TCP socket is automatically going to be running out of the window. So basically pushing back on the TCP window if the CAN bus is busy. So if you can't actually take the bytes of the TCP socket, then your sender is going to be throttled by the window. If you are using Ubiquiti, I actually do have a challenge for you, and I would love for you to actually take a look at this. The Ubiquiti runs Linux on the routers, obviously. Almost everybody does, but they do as well. You can actually SSH into a Ubiquiti access point. I would really love for somebody to take OpenMRN and compile it for the Ubiquiti so that they would run the hub actually on the Wi-Fi access point. That would be amazing. That would be amazing because then you could basically like take this one device, this puck, this Ubiquiti puck, and you bring it with you to the show or the Freemo meet or whatever, and then you have basically unlimited Wi-Fi connections and no throughput concern and no concern about TCP sockets and everything, and it all just works. That would be amazing.
Do you know what their technology is? They won't have an SDK or anything, right? I have never looked at that, but
I don't know. I mean, I SSH'd in and it looked like a Linux, and I could use, like command line utilities. It probably has a MIPS processor, but that doesn't matter. It's a 32-bit processor. So it shouldn't be terribly difficult. You clearly need to cross compile because there's not going to be a compiler on the on the puck that you mount on the wall. But that's a solvable problem.
Interesting.
I would love for this to happen. And if somebody actually does this, I will push real hard for that device to actually be sold. Because it would be incredibly useful. Like, people want to use like 20 or 30 of these Wi-Fi throttles, and that is basically the holy grail that they're looking for. Like a Wi-Fi access point that can do 200 clients, like Ubiquiti one, and has the hub process built in, the software with the TCP sockets and everything.
We've got a Freemo meet on 19th, 20th, 21st, 22nd of this month coming up. So I usually run JMRI on my on a Mac laptop, and I've got a Ubiquiti Wi-Fi access point, just one of them, and that's enough for a big double basketball court space. And there's about 25, 30 guys there with their smartphones or their various Wi-Fi throttles that they've got. It seems to work well. The problem is not Wi-Fi. It's usually some cabling or something going wrong somewhere, but that has worked quite well for us in the past. And but for Freemo, I've made a bunch of the little Loconet panels to for a cheap solution for the guys to have a Freemo compliant module, and I've probably done about 250 of those things, and I think we'll probably have about 100 modules at least. And but I do wonder about running a hybrid environment with Loconet plus LCC on Wi-Fi, Loconet on cable. I doubt no one will want to run yet another cable between Freemo modules. So it's like, okay, how can we start to utilize LCC in the Freemo environment without the effort of running more cables? So hence my interest. Yeah.
I mean, it is definitely possible to run LCC via Wi-Fi. Usually you would want to run it, depending on how many devices you have per island, you usually end up having these LCC islands. And in an island, you have a couple of connected modules that have LCC on them, and maybe they are connected with cables. And then for each module, you would have one ESP32 that acts as basically a Wi-Fi to CAN gateway. And then all of these then connect back to your laptop. And that's powerful enough, because then the Wi-Fi to CAN gateway, they only handle one connection, the one to the laptop, and nobody else. And that is perfectly fine. That is perfectly within reach of the ESP32.
Lots of potential, I must admit. It's I've got to now look at the ESP32 a bit more, and then maybe the S1032s. I've not played with them yet. I'm just wondering, has anybody any questions from what they've seen in the presentation so far?
I always have lots of questions, but I'll wait for a bit. Do you have an opinion on ESP32 versus STM32, sort of reliability or?
I think they both have their appropriate places. For anybody doing a real product in a real embedded environment in a model railroad, etc., I recommend the STM32. And not this one specifically. I recommend the STM32L4. The L4 has a little bit of extra, security support. I recommend these two for hobbyists because this is very cheap. So I think it's like $11 for this board, and it has like a crazy number of IOs. I think I mentioned that. So the STM32s are extremely robust and very reliable and very predictable. ESP32 has so for professional environments, I recommend it only if you are Wi-Fi based. If you are Wi-Fi based and there is no other option within your constraints of budgeting and size. These are, for example, Wi-Fi based, but they do not contain an ESP32. They contain a Texas Instruments chip. And I trust the Texas Instrument a lot better. And we have not had any reliability issues with this. The ESP32 is great for hobbyists because of the wide set of features. The difficulty with the ESP32 can be that it's an extremely dynamic and evolving environment. So you need to somehow keep up. Like they have new software releases for the ESP32 like twice a year or something like that. And who really has time in order to do like full release qualification and testing and everything like twice a year? That is just crazy. So that I find a bit of a challenge. The quality of the supporting software and middleware for the ESP32 is actually much higher than any microcontroller development team that I have ever seen. That includes TI as well and STM32. TI and STM32, their middleware is so-so. ESP32, the middleware has a lot of contributions from the open source community who have like really good programmers. So the middleware is higher quality, but unfortunately that also means that it is evolving in this sense all the time. And that is that can be quite tricky. If you do this full time, keeping up is not necessarily a problem. But if you are a small manufacturer with like maybe a 1 or 2% team, it's going to be very difficult to keep up just with release qualification.
At one point, the ESP32 Wi-Fi stack used to disable interrupts for like a millisecond or something, right? Is that problem gone away?
I don't know. We don't really care about that because 1 millisecond is not something that we actually don't survive. Because 1 millisecond is like perfectly within reach of the queuing for the CAN bus.
I think it was in the context of a DCC command station that was causing the grief because it was messing up the packet generation. Or there was a it was within 2 or 3 years.
I haven't heard this concern, even though I did talk to Mike Dunstan. I mean, Mike Dunstan is building his command station based on the ESP32, and he hasn't complained about it. But maybe he's using the hardware peripheral for the packet generation for DCC. And probably he's using a multi-core ESP32. So you can probably, like separate your DCC to one core and then your Wi-Fi and other higher level concerts to another core. You can actually do that within an ESP32.
Oh, Balazs, what do you think about the Pico?
I never played with it. I mean, it's obviously a pretty powerful microcontroller. It is the fact that it has external flash basically means that most of the code size concerns that we have with microcontrollers, like this blue pill or whatever, all of those are obviously gone. Like the smallest I've seen is 2 megs. It's huge. the core that it has, it's an ARM core. I don't know, it's an M33 or something like that, or an M4. It has 2 cores as well, which can be tricky. But even if you only use 1 core of it, that's perfectly fine. The only problem I have with the Pi Pico is it doesn't have a built-in CAN peripheral. If it had a CAN peripheral, it would be perfect.
Yeah.
But because it doesn't have one, and I wouldn't trust an open source implementation, open source software implementation of CAN bus for real production use cases. With an external CAN transceiver and CAN controller, it's fine. But then you need to have like the right choice of the CAN controller, like the 2517 or 25017 or 018 is fine.
And it's got Wi-Fi versions too, so you could use Wi-Fi.
But it's not built in. So the Wi-Fi version basically just attaches like an ESP32 or something like that externally.
Yeah, it's some dedicated chip, I think.
Okay, well then dedicated chip. And I don't know how much RAM it has. I don't think it has a crazy amount of RAM. So eventually with Wi-Fi, you're also running out of RAM, and you're also running out of juice. So that one is it's probably comparable to an ESP32 without actually having the ecosystem around it.
You, in the examples earlier in the presentation, you had hard-coded event IDs, but those pin type handlers, you had a bunch of different sort of IO handlers, and then at the sort of halfway through, you said, "Oh, here's the ones that have the configurable producers."
Yeah.
Do you have the same nice, convenient IO handlers in those versions as well?
You mean like the GPIOs here?
Yeah, all the GPIO, pole handler, and you had different flavors of IO, and then you sort of said, "Oh, here's the configurable, or here's the event handler for that you can set the IDs for." But
yeah. I think I stopped sharing the screen for some reason. Yeah. I don't know why. Let me finish. Let me do it again. Yeah, I want to share the example from yeah. So this is 16 LAD. So here, this is from Robert Haller, this example. So this is the place where he actually declares the GPIO pins. He uses the direct form of the GPIO object that he declared. And here are the actual definitions of them. And after you made these definitions, you can use them. You can use these abstract GPIOs, even though they are on an extender chip. You can use them in those producers and consumers as well. So it doesn't matter what kind of GPIO object you have, whether you have like an Arduino GPIO, an ESP32 GPIO, an STM32 GPIO, or like this 23017 GPIO. It all works with all of the configurable producers. Did this answer your question? I'm not 100% sure.
Can you just bring your presentation up?
Okay, so this was the configurable producer and consumer here. Sorry,
yeah,
this was the fixed one, right?
Yeah.
And it has the GPIO pin, and then this is a configured one. I don't have the code example here. I can show.
So the difference between configured and fixed. Do you have all the same functionality for the type of pin, independent of whether it's fixed configuration or it's configurable?
Do you have a configured bit?
Yeah.
I mean, the type of pin. So when you're talking about a pin, like an
no, it's
pin,
just the.
That's always a bool on off. So so the pin is always a 2-event construction, and it doesn't matter what kind of pin it is. You can put it in the configured producer consumer.
Right. I get it. So you define the pin the way you want it with the first ones you showed us, and then you take that definition, you can put it into the configured producer.
It just sounded like to me that you could do more with the fixed ones than the configured one, or the fixed producer consumers had more features than the configured one, but perhaps that's just the limitation of what you're.
So yeah. I have okay. So some of them are by nature, right? So the DCC accessory, these are by nature fixed. These are fixed because they are well-known events.
Right.
But for example, like this byte range event consumer producer, this is like a very specific thing. This one I have only ever written with a fixed event ID. I've never written like a configurable byte range event consumer, if that's what you're asking. Yeah. So if you need one, then somebody needs to write it. Like either I can write it for you, or you write it yourself. This one only exists in fixed version. If you want to transfer between the fixed and the configurable, nothing prevents you from reading your storage in begin. If you read your storage in begin, and then you can instantiate the fixed producers with the number that you just read out of your storage. So technically, there is a little bit of like a switchover where you can use the fixed versions with configurable numbers. But there's going to be a little bit of constraints in there. So for example, every time you change your configuration, you have to reboot the node, which is doable. It's not hard.
Yeah. So
you can even make the node automatically reboot every time that you decide to change the configuration.
Because we generate an event end of configuration or something, so a node can reboot.
There is a message. There is a message that goes out in the datagrams,
yes.
and then you can tell OpenMRN, if you get this, just reboot.
I haven't really played with this code base at all, so I was curious, very curious to listen to what you had to say. Excellent.
Me too.
I think the thing is, with your sharing the other fellows' libraries as well, there's a lot for us to now look at and take in.
Mm-hmm.
That's going to help a lot of us now. So it's been appreciated being able to see what's been made available. And the fact that you've revisited the library last month to make it so it will compile again within the Arduino IDE, I think is very powerful. I know obviously some people use Platform IO. I've not really played with that myself. So there's a lot to take in.
Okay, cool. If you have any questions, I'm happy to answer. If you still have any right now, we can go through them, or you can come back later on the OpenLCB mailing list. There's even a mailing list for OpenMRN developers, although it's completely dead. Like nobody ever writes there.